بسم الله الرحمن الرحيم والصلاة والسلام على المبعوث رحمة للعالمين سيدنا محمد وعلى آله وصحبه أجمعين. Your Excellency Mr. Eid Al-Faiz, Board of Al-Zaytuna Trustees Chair, the patron of the ICIT 2021 Conference Opening Ceremony, Professor Muhammad Al-Majali, the President of Al-Zaytuna University of Jordan, Your Excellency's Board of Trustees members, Your Excellency Engineer Iyad Al-Qarim, Board of Directors Chair and Board of Directors, Honorable Professor Artyom Rekon, the Vice Rector of Tomsk State University, Russia, Your Excellency Dr. Ala Khalifa, the President of IEEE Jordan Section, Professors, Faculty Deans, Conference participants, dear colleagues, distinguished audience, Assalamu alaikum wa rahmatullahi wa barakatuh. Today, Al-Zaytuna University of Jordan is honored to have you here at the 10th International Conference on Information Technology, which is organized and hosted by Al-Zaytuna University of Jordan in cooperation with Tomsk State University and IEEE Jordan Section. The ICIT conference and other conferences that we are having here in Al-Zaytuna present live evidence that Al-Zaytuna is advancing to become one of the leading universities, not only locally, but also on the region and the global scales. Now, we are going to start our opening session with Quran verse recitation by Mu'adh Abu Khadra.
أعوذ بالله من الشيطان الرجيم. يا أيها الذين آمنوا إذا تناجيتم فلا تتناجوا بالإثم والعدوان ومعصية الرسول، وتناجوا بالبر والتقوى، واتقوا الله الذي إليه تحشرون. إنما النجوى من الشيطان ليحزن الذين آمنوا وليس بضارهم شيئا إلا بإذن الله، وعلى الله فليتوكل المؤمنون. يا أيها الذين آمنوا إذا قيل لكم تفسحوا في المجالس فافسحوا يفسح الله لكم، وإذا قيل انشزوا فانشزوا يرفع الله الذين آمنوا منكم والذين أوتوا العلم درجات، والله بما تعملون خبير. صدق الله العظيم.
صدق الله العظيم. ICIT conference has been organized for the first time in 2003 and continued as a biannual international conference. Since then, the ICIT gradually get more attention and become more known to the researchers. In 2003, the conference started with 46 papers to reach today to more than 170 papers. In every ICIT conference, since the first one, there is a theme. This conference theme is Advanced Machine Learning and Deep Learning, which is the cutting-edge research nowadays. Choosing themes shows how the conference is strongly related to the updated technologies, which gives it more credit and more reputation. Please Welcome Professor Amjad Zriqat, the conference chair.
السلام عليكم. بسم الله الرحمن الرحيم. الحمد لله رب العالمين، والصلاة والسلام على المبعوث رحمة للعالمين معلم البشرية سيدنا محمد وعلى آله وصحبه أجمعين ومن اقتفى على أثارهم إلى يوم الدين. قال تعالى بعد أعوذ بالله من الشيطان الرجيم، بسم الله الرحمن الرحيم. يرفع الله الذين آمنوا منكم والذين أوتوا العلم درجات. وقال عز وجل: قل هل يستوي الذين يعلمون والذين لا يعلمون إنما يتفكر أولي الألباب. معالي السيد عيد الفايز رئيس مجلس أمناء الجامعة الأكرم راعي الحفل الكريم، عطوفة الأستاذ الدكتور محمد المجالي رئيس الجامعة الأكرم، نائب رئيس جامعة تومسك الروسية الحكومية بروفيسور أرتوم ريكون الأكرم، سعادة الملحق الثقافي الروسي في المملكة الأردنية الهاشمية، المستشار الأول للسفير الروسي في سفارة روسيا الاتحادية السيد أليكسي بوكين، أصحاب المعالي والسعادة والعطوفة، الحضور المشاركين الكرام وضيوف الجامعة، زملاء العمداء وأعضاء الهيئتين التدريسية والإدارية، أيها الحفل الكريم، السلام عليكم ورحمة الله وبركاته. لطالما كانت رؤية جلالة الملك عبد الله الثاني بن الحسين في جعل الأردن مركزاً إقليمياً لتكنولوجيا المعلومات البوصلة التي نتبعها والدافع للعمل الدؤوب لتحقيق هذه الرؤية، وكما جاء في الورقة النقاشية السابعة لحضرة صاحب الجلالة بأنه على المؤسسات التعليمية أن تثق بأبناء هذا الشعب وبناته من طاقات هائلة وقدرات كبيرة ومواهب متنوعة، وتجسيدا منا لهذه الرؤية وإيمانا منا بهذا الدور الريادي، جاء التصميم والاستمرار في عقد المؤتمر الدولي لتكنولوجيا المعلومات في نسخته 10 لهذا العام، وبعنوان Advanced Machine Learning and Deep Learning، ليتزامن هذا المؤتمر مع فعاليات واحتفالات جامعة الزيتون الأردنية بمناسبة السنوية الأولى المئوية الأولى لتأسيس المملكة الأردنية الهاشمية. ورغم كل الظروف التي يمر بها العالم أجمع وليس الأردن فقط لجائحة كورونا، حيث يعقد هذا المؤتمر لهذا العام مع جامعة تومسك الحكومية الروسية ومجمع ICIT العالمية فرع الأردن، ليمنح الفرصة للباحثين من أبناء هذا الوطن ليطلعوا على آخر التطورات في عالم الاتصالات وتكنولوجيا المعلومات، ويسهموا في فتح الآفاق لهم للتواصل مع الباحثين من مختلف أنحاء العالم. فباسم أسرة كلية العلوم وتكنولوجيا المعلومات في جامعة الزيتون الأردنية أرحب بكم جميعاً، شاكراً لكم تلبية دعوتنا للمشاركة في افتتاح هذا الحدث العلمي المتميز، متوجهاً بالتحية والشكر لكل المشاركين من جميع الدول الذين رفضوا هذا المؤتمر بدراسات أو أبحاث علمية والتي تم الاطلاع عليها وتحكيمها واعتمادها للنشر في وقائع هذا المؤتمر. كما وأتقدم بالشكر والعرفان لأسرة كلية العلوم وتكنولوجيا المعلومات من الهيئتين التدريسية والإدارية، وعلى رأسهم اللجنة التحضيرية لهذا المؤتمر، لتقديمهم نموذجاً راقياً في التناغم والعمل بروح الفريق الواحد، والذي أسهم بتحقيق نقلة نوعية في مستوى الأداء والتنظيم، والذي ستلمسونه خلال أعمال هذا المؤتمر إن شاء الله. وأؤكد التأكيد على المشاركة الحقيقية والفاعلة والإضافة النوعية لجامعة تومسك الروسية في هذا المؤتمر، فلهم منا كل الشكر وخالص العرفان. وأود الشكر لمجمع IEEE العالمية فرع الأردن، ممثلة بفرعها في الأردن، وعلى رأسهم الأستاذ الدكتور علاء خليفة. وأخص بالشكر والثناء للمتحدثين الرئيسيين في هذا المؤتمر: بروفيسور سفيتلانا مايسيفا، جامعة تومسك الروسية، روسيا الاتحادية; بروفيسور منادياب، جامعة جورج واشنطن، الولايات المتحدة الأمريكية; بروفيسور روبرت رامبل، جامعة بوزنان التكنولوجية، بولندا; والدكتور علاء انشيوات، المدير التنفيذي لمحفظة أمنية الإلكترونية، المملكة الأردنية الهاشمية. أيها الحفل الكريم، اسمحوا لي أن أقدم لكم موجزاً عن مؤتمرنا. بلغ عدد الأبحاث التي تم استلامها من الباحثين من جميع دول العالم 319 بحث. تم قبول 176 بحثاً منها، أي بما نسبته 55% من مجموع هذه الأبحاث. وتوزعت هذه الأبحاث على 42 دولة عربية وأجنبية. وكان عدد الباحثين في هذه الأبحاث 176 673 باحثاً. أما الدول ف10 دول عربية، منها الأردن، الإمارات، البحرين، الجزائر، السعودية، قطر، العراق، تونس، فلسطين، مصر. والدول الأجنبية 31 دولة: روسيا الاتحادية، استراليا، الولايات المتحدة الأمريكية، إسبانيا، باكستان، بريطانيا، ألمانيا، الهند، تركيا، بنغلاديش، بولندا، إيطاليا، مالطا، ماليزيا، كينيا، سنغافورة، هنغاريا، فيتنام، أذربيجان، الصين، بيلاروسيا، التشيك، إثيوبيا، هونغ كونغ، أوكرانيا، المكسيك، الفلبين، سريلانكا، رواندا، إيران، إندونيسيا. تركزت أوراق البحوث المشاركة في المؤتمر بشكل عام حول المحاور التالية: علم البيانات، النظم الذكية، الأمن السيبراني، التحليل والنمذجة الرياضية، هندسة البرمجيات، إنترنت الأشياء. وتم إضافة محور جديد في هذا المؤتمر خاص بالحلول التقنية والتكنولوجية لجائحة كورونا. تم توزيع البحوث 176 على 28 جلسة على يومين متتاليين. تم توزيعها على 7 قاعات تعمل بشكل مدمج وعن بعد، وقد تم اتخاذ جميع الإجراءات اللازمة بالتعليمات الصحية. وستكون جميع هذه الجلسات كما قلت وجاهيا وعن بعد. يعني للعلم أن الآن نحن في هذه الافتتاحية يبث هذا الحفل إلى أكثر من 42 دولة حول العالم. يعني أرجو تزويدي بعدد الآن المشاهدين لهذا المؤتمر، لهذه الافتتاحية في هذا الوقت المباشر. Today our ceremony is translated around the world for 42 countries. أيها السيدات والسادة، أود التأكيد هنا على أن الرعاية الكريمة لمعالي السيد عيد الفايز أتت تتويجا للجهود المبذولة في إنجاح أعمال هذا المؤتمر، وذلك لما يتمتع به معاليه من خبرة علمية وعملية واسعة في المجال الاجتماعي والاقتصادي والسياسي في القطاعين العام والخاص. فهو السياسي الذي تبوأ عدة حقائب وزارية وتنقل في العديد من المناصب التي جعلته على دراية تامة في الشأنين العام والخاص، فله منا كل الشكر ووافر الامتنان. كما وأتقدم بالشكر من عطوفة الأستاذ الدكتور محمد المجالي رئيس الجامعة، الذي تفضل مشكورا بدعم هذا المؤتمر وتشجيعه منذ بدايته، وليس ذلك بغريب عن عطوفته، وهو الذي يحرص دائما على تشجيع البحث العلمي. ونخص بجزيل الشكر والعرفان سعادة رئيس هيئة المديرين المهندس إياد القرم، وأعضاء الهيئة الكرام لدعمهم المتميز لإنجاح هذا المؤتمر. أيها الأخوة والأخوات، دعوني أرحب بكم مرة أخرى ومكررا شكري لجميع الحضور، آملا أن يحقق مؤتمرنا هذا جميع أهدافه، ومتمنيا لكم ضيوفنا الكرام أجمل إقامة في ربوع وطننا الحبيب الأردن، وفي ظل قيادتنا الهاشمية الحكيمة. حفظ الله الأردن وطنا للخير والعطاء والحضارة والبناء، آمنا عزيزا بقيادة صاحب جلالة الملك عبد الله الثاني بن الحسين حفظه الله ورعاه. فأهلا وسهلا بكم مرة أخرى في رحاب جامعتكم جامعة الزيتون الأردنية، وفقكم الله، والسلام عليكم ورحمة الله وبركاته.
Thank you, Professor Amjad. This year, the ICIT conference is organized in joint with another research body, Tomsk State University from Russia. Tomsk State University was founded in 1878. It is the oldest university in the Russian Asia, in Siberia. Also, it was the first Siberian Imperial University. Please welcome Professor Artyom Rekun, the Vice Rector in Tomsk State University.
Dear President Muhammad Ahmad Al-Majali, dear Alexei Valerievich Bukin, dear Director, dear Professor Amjad Rikat, dear colleagues, It is my pleasure to be here today, and on behalf of Tomsk State University and on my own behalf, let me thank Al Zaytuna University of Jordan for the invitation to the 10th International Conference on Information Technology and for the warm welcome we received here. Al Zaytuna University of Jordan is an outstanding institution with a track record of educational and research excellence, and its growth can be witnessed in developing new areas and in their application. Such areas as machine learning and data science, software engineering shape the future, and pursuing research in these areas marks a university as innovative and ultra-modern. Holding conferences like this proves the desire to participate in global research dialogue, openness to the new knowledge and development. We are honored to be partners of Al Zaytuna University of Jordan. My university, Tomsk State, is truly the oldest beyond the Ural Mountains, and you just imagine the huge territory from the Ural Mountains to the Pacific Ocean and from the Arctic Ocean to the southern borders of Russian Empire. They did include Russian Central Asia, like Uzbekistan. So for 10 years, we were the only institution of higher education in that huge territory. And besides that, TSU, since that time, strives to enhance and promote research and academic cooperation. It has also taken various initiatives to complement our educational excellence. TSU currently is ranked 272nd in QS Global University Rankings and 4th among Russian universities, right after Moscow State, St. Petersburg State, and Novosibirsk State. We hope that the cooperation between our universities will be successful and fruitful. In times of global challenges and changes, it is important to share and apply knowledge and innovations to the current situations to stay afloat in the sea of uncertainty, which the pandemic showed us we are actually in. Let me once again thank you for the welcoming our delegation on the 10th International Conference on Information Technology. Also, I would like personally to thank Professor Amjad Rikat, the General Chair of the conference, for his dedication and efforts in both organizing this global event, the conference, in extremely difficult times and in strengthening the academic ties between the Hashemite Kingdom of Jordan and my country. I wish for this conference to be beneficial for all the parties and for all the participants to stay healthy. Thank you.
Thank you, Professor Artyom. By the way, this ceremony is streaming live through social media and Zoom platform with more than 300 virtual attendees. Nowadays, after more than 2.5 decades of the university founding, Al-Zaytuna University is very proud of the qualified graduates and the services that have been provided, not only for the local communities and their industry, but also for the region. Today, the university contains 8 faculties that offer more than 30 undergraduate programs, in addition to the 11 master programs in IT, pharmacology, business, literature, law, and nursing. Please welcome Professor Mohammed Al-Majali, the president of Al-Zaytuna University of Jordan.
بسم الله الرحمن الرحيم والصلاة والسلام على سيدنا محمد وعلى آله وصحبه أجمعين. مع الأستاذ عيد الفايز الأكرم رئيس مجلس أمناء الجامعة راعي الحفل الكريم، الأساتذة العلماء الأجلاء، ضيوف الجامعة من داخل الأردن وخارجه، الأساتذة عمداء الكليات الأفاضل، أيها الحفل الكريم، السلام عليكم ورحمة الله وبركاته. فإنه لشرف عظيم أن نلتقي في رحاب جامعة الزيتونة الأردنية بعد انقطاع دام لأكثر من عام، عانينا فيه معاناة شديدة بفعل جائحة كورونا، تلك الجائحة التي اجتاحت العالم كله وحصدت أرواح كثير من الناس، وهي لا تزال تقلقنا وتؤرقنا وتجعلنا أكثر حذراً والتزاماً نظراً لانعكاساتها السلبية على مناحي الحياة كافة، الاجتماعية والاقتصادية والسياسية والتعليمية. راجين الله عز وجل أن تكون نهاية هذا الوباء قريبة، وأن تحمل الأيام القادمة بشائر الخير والطمأنينة لزمن أجمل، لتعود عجلة العمل والبحث والتنقيب في كل جامعاتنا من جديد، ولنعزز لقاءاتنا العلمية الهادفة لما فيه مصلحة الجميع. الأساتذة الأجلاء، ضيوف الجامعة، نرحب بكم في جامعة الزيتونة الأردنية أجمل ترحيب، ونرحب بجميع المشاركين من خارج الأردن أيضاً، ممن شرفونا بمشاركتهم وحرصوا على متابعة حفل الافتتاح وجلسات المؤتمر عن بعد، فلهم منا تحية تقدير واحترام، آملين من الله أن يجمعنا بهم في لقاءات قادمة في رحاب هذه الجامعة وهم بأتم الصحة والعافية. أيها الحفل الكريم، لقد جاء انعقاد مؤتمر كلية العلوم الدوري العاشر بالتعاون مع جامعة تومسك الروسية تعزيزاً لرسالة جامعة الزيتونة الأردنية الرامية إلى الارتقاء بواقع البحث العلمي وتوطيد أواصر المحبة والتعاون مع الأساتذة الأجلاء في الجامعات العالمية والعربية والمحلية، والسمو بالمشهد الثقافي الذي كان ولا يزال يشكل نموذجاً راقياً للثقافات المختلفة. وإنه لمن حسن الطالع أن يأتي انعقاد هذا المؤتمر متزامناً مع احتفالاتنا بمئوية الدولة الأردنية، هذه المئوية التي حملت معها إنجازات عظيمة وتطورات هائلة في كافة المجالات السياسية والاقتصادية والاجتماعية والتعليمية والصحية، وجعلت الأردن محط إعجاب الجميع. والله نسأل أن يحفظ الأردن وقيادته الهاشمية الفذة الحكيمة. أيها الحفل الكريم، لقد حرصنا في إعدادنا لهذا المؤتمر على أن لا يكون مؤتمراً تقليدياً في عنوانه ومعالجاته، وأن يكون فيه من الحداثة والكشف والاستشراف ما يؤشر على قيمته العلمية. لذا فقد صيغت محاوره بدقة وعناية، شارك في وضعها مجموعة من الأساتذة الأفاضل ممن وجدوا فيه متسعاً كبيراً للتجديد والإبداع والابتكار، ذلك أننا نعيش في زمن يحتم علينا أن نكون أكثر استشرافاً في الطرح وعمقاً في المعالجة وتخففاً من التقليد المنفر. فالعالم لا يتغير بالاتفاق معه، إنما يتغير بالاختلاف معه، والذين غيروا العالم عبر حقب التاريخ هم الذين كانوا دائماً على خلاف معه. لقد جاءت محاور هذا المؤتمر منسجمة متناغمة مع أهدافه، وإنه لشرف كبير أن يتقدم للمشاركة فيه 319 بحثاً حكمت جميعها بموضوعية وأمانة ودقة، وتمت الموافقة على 176 بحثاً من أكثر من 40 دولة. أيها الحفل الكريم، إن الحراك الثقافي في جامعتنا الحبيبة جامعة الزيتون الأردنية وتطور البحث العلمي وتميزه ما كان ليتأتى دون دعم القائمين المؤسسين لهذه الجامعة وتوجيهات مجلس أمناء الجامعة الأكارم وتعاون الأساتذة والإداريين فيها، فتحية تقدير واحترام لهم جميعاً. واسمحوا لي أن أخص بالشكر في هذا المقام عميد كلية العلوم وأعضاء الهيئتين التدريسية والإدارية فيها، الذين أسهموا في الإعداد لهذا المؤتمر وعملوا ليل نهارا لإنجاحه، آملاً من الله عز وجل أن تأتي توصيات هذا المؤتمر قيمة ثرية غنية تخدم الأهداف التي عقد من أجلها. مرة أخرى أرحب بكم جميعاً، وأشكر راعي الحفل الكريم معالي الأستاذ عيد الفايز رئيس مجلس الأمناء الذي تفضل مشكوراً برعاية هذا المؤتمر، فله منا كل التحايا والتقدير، مؤكدين أن هذه الجامعة ستظل صرحاً علمياً شامخاً يلتقي فيه الجميع على الحب والخير والانتماء والعطاء. والسلام عليكم ورحمة الله.
Thank you, Professor Muhammad. His Excellency Mr. Eid Al-Faiz, Board of Al-Zaytuna Trustees Chair, the patron of the ICIT 2021 Conference Opening Ceremony, want to talk to you in a few minutes with a few words, please.
بسم الله والحمد لله والصلاة والسلام على رسول الله. بسم الله الواحد القهار. ثبت لي إياه. بسم الله الواحد القهار العزيز الجبار الرحيم الغفار الذي لا تخفى عليه الأسرار، خلق كل شيء بمقدار. After what I heard about the University of Zaytuna, I'm proud to be here because I served in this university for almost 21 years. I'm proud in every piece in this university. I'm proud of everybody work in the university, in this university. I am proud of the leaders, Dr. Muhammad, Dr. Amjad, all the Umada, everybody here. I'm proud of them. I am proud of this university because it's one of the leaders of the universities in Jordan. It considered, in my opinion, and most of the other people's opinions, one of the most university here in Jordan, advanced in everything, not in technology. This university is built up by the founder of this university. We appreciate every step he did for this university. He's a pioneer. He is the one who lead this university to what it is now. I thank you all who came abroad from all the world to this university to participate in the research and give what you can to give this university little bit advanced, more what we did. I thank the University of Tomsk. I thank the Embassy of Russia. Thank everybody in this hall. The students in this university, I don't know whether it's big or small, but it's over 8,000 students here in this Jordan. For the Jordanian universities, it's considered one of the best between the universities. It's 8,000 people. And without those people around me, we will never reach that number. We socialized here in the environment here. It's not easy to contain all the differences in this region. Thanks for everybody here. Thank you, people, each one in his name. Thanks for everyone who want to give a paper, and be sure that we appreciate your presence here, and I hope we can do a lot for you more than what we did. Thank you very much. Thank you, Dr. Muhammad. Thank you, Dr. Ramble. Thank you, everybody.
Thank you, Your Excellency, for this inspiring speech. The 10th International Conference of Information Technology is full of innovation ideas that will be presented, in addition to discussions that should enrich the field of IT and benefits the researchers and attendees. His Excellency, Mr. Eid Al-Faiz, Board of Al-Zaytuna Trustees Chair, will now honor the keynote speakers and distinguished conference partners with the Zaytuna shields. Please. And they are Professor Artyom Raikon from Tomsk State University, Russia. Dr. Ala Khalifa from IEEE Jordan Section. Professor Svetlana Moyaseva, National Research, Tomsk State University. Dr. Ala Inshewat from UWallet, Jordan. And our sponsor, Omnia Jordan. دكتور علاء ممكن ياخذ أمي دكتور. صورة مع Okay. Dear participants, please be safe and keep social distance and wear the mask all the time during the conference. Dear participants, again, please keep the social distance and wear the mask all the time during the conference activities and sessions. Thank you everyone for your attending the opening ceremony of the International Conference on Information Technology. السلام الملكي. All attendees, please gathering on the main door with the keep social distancing for taking several group photos. Thank you. There will be also a coffee break after the photo.
Hello, can you hear me? Hello, hello.
Hello, Professor Robert.
Hey, hi.
Hi. Just give us five minutes because we are a bit late in the opening session. 5 minutes, we will start, okay?
Okay, yes.
Yeah, okay.
بسم الله الرحمن الرحيم. اوكي دكتور بلش. طب انا بدي اشوفه.
بدي اروح لا بس اشوف وين يعني مش هناك هون رح نقعد. اه هلا اروح ولما يجي دوري خليك
في راح يكون واحد اونلاين يعني. بس لا 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 ما في بس عليك. شوف في مجال تبعث لي اللينك واتساب زوم.
دكتور ما في شيء مبين صح؟ شاشه سوداء حاليا. ايوه. لايك تاس. خلاص. دكتور هو سامعني هسه؟ Good morning, ladies and gentlemen. Our keynote speaker today is Professor Robert Ramble. Robert Ramble is a professor in Faculty of Computing at Poznań University of Technology in Poland. He's specialized in database systems and data warehousing. Robert Ramble involved in 8 research and 8 industrial projects in the area of data processing technologies. Consultant at Software House Radan Systems, lecturer at Oracle, Poland. Currently, he leads at his university the Erasmus Mundus Joint Doctorate Program. Professor Ramble talk titled is Selected Open Problems in Building Data Processing Workflows. Today, he will address his subjective point of view on the problem on designing data integration process based on recently run projects in several areas. So welcome with me, Professor Ramble.
Okay, thank you. First of all, thank you for the invitation. It's my honor to give this talk. And I'm going to start with the outline. Okay, the talk will be on data integration architectures to give you the big picture. And in particular, I will focus on the following 4 challenges. First, performance optimization of data processing workflows. This, this experience comes from a project with IBM Software Lab in Poland. Challenge number 2 is on opening user-defined functions. This is again outcome from a project with the same IBM Software Lab. Challenge number 3 is on end-to-end data processing workflow design method. This is the outcome of my project with Universitat Politècnica de Catalunya in Barcelona. And finally, I will just 2 slides on integrating medical data. And this comes from another project with a private hospital in Poland. So I will start with this chart that shows the number of publications per year on data integration. Generally, the search keyword was data integration. It's based on DBLP. So as we can observe, the topic, the interest of research community grows in time. And there are 5 the most widely used, cited, reference data integration architectures: federated, mediated, of course, data warehouse, then data lake and polystore. And well, briefly, let's go through them. The mediated architecture, it's a virtual integration. There are data sources and there are users, and in between the users and data sources, there is an integration layer. So data are stored only in their original data sources and they are integrated on the fly. That means while needed. Another integration architecture, again, virtual, it's federated. Again, data sources at the bottom, the users at the top, and in between, again, an integration layer. This time it's slightly more complicated, but the idea is exactly the same as in the mediated architecture. And then we move to a physical integration. The most well-known is a data warehouse. Data coming from data sources are integrated, and these integrated data are stored in a central repository called a data warehouse. It's a kind of batch integration. since data are integrated once per a given period of time, typically once per day. The next one is a data lake, well known, again, data sources, the users, and in between, again, the integration layer. And this time it's composed of a data lake that stores all data dumps from data sources. These data in the data lake are in their original format, highly heterogeneous, raw formats, different types of data, typically stored in a distributed file system. And of course, you cannot analyze such a mess of data, dirty data, unstructured data. It's impossible to analyze them efficiently. So you have to, again, integrate these data, and people are building data warehouses on a data lake, and they are building federated or mediated architectures on data lake to provide integrated view on data, on some data in the data lake. So I call this physical integration because there are physically stored data, plus virtual integration because this component integrates data virtually. And finally, the polystore, it's again physical plus virtual. The idea of the polystore is as follows. There are storage systems that store data expressed in the same data model. Let's call this blue data model, model 1, could be relational. Then there is another storage system that stores the green data expressed in the green data model, could be a graph, for example. And the third one, the red one, is, let's say, NoSQL. And then these storage systems can be integrated virtually by means of kind of software that is either typically a kind of mediated architectures applied to this virtual integration. So for example, we can view these graph of green data as if they were relational using this integrated view. Similarly, you can view these graph data as if they were NoSQL through this integrated view. So that's the basic idea of the policy. And I mentioned 5 the most typical data integration architectures, and they share the same concept, and they express or they experience the same problems, because in between data sources and the user, there is a data integration layer. Always, in all these architectures, there is a challenge in integrating heterogeneous and distributed data. So this layer in between, this integration layer is called data integration pipeline, ETL, extract, transform, load in data warehouses, data processing pipeline in data science, data processing workflow, different names on a functionality that allows us to integrate data. So this software executes data integration processes that are composed of sequences of tasks. Task E, task T, task C. In the most typical ETL data integration, these data integration processes execute tasks: ingesting, transforming data into a common data model, common data structures, cleaning, homogenizing, deduplicating, and uploading into either a central repository, if this is a physical integration, or providing these integrating data to the user, if this is a virtual integration. So now the first challenge, the performance optimization of data integration processes. Typically, we are using magnetic disks with throughput about 200 megabytes per second. And just can we imagine just reading and writing 1 terabyte from the same disk, from one place of this into another place over this. And to move this, just copy paste these 200, oh, sorry, to copy paste 1 terabyte of data takes 160 minutes. That's quite substantial. And then add to it time for executing all these processes. So this time can increase n times, depending on how complex these tasks are. So the conclusion is that ETL, or data integration processes performance, is that the performance of such processes is vital to the whole system. And the goal, we would like to be able to optimize the execution of such data integration processes. And the goal, ultimate, I would say, this is my subjective point of view, an ultimate goal would be to have a kind of SQL-like optimization based on costs, execution costs. Okay, so to do this, we would need to have a data integration process execution plan and its optimization methods based on costs. But there is a problem to achieve this SQL-like optimization. Problem one is we have to have statistics. In databases, statistics are available all the time. You can compute them while needed beforehand, but while executing ETL or data integration processes, data come and then you have to compute these statistics. We don't have statistics beforehand because you don't have these data that are to be integrated. So you have to compute the statistics, data statistics on the fly that adds to this processing time even more because you have to compute statistics. Then there is another problem. Analyzing, you have to analyze, to be able to optimize data processing, data integration process, you have to analyze the workflow of tasks to discover redundant parts. Okay, there are different designs of data integration processes. Better, more efficient, less efficient. There are some may appear some redundant parts that do the same. So like in SQL, you may have redundant parts. If you remove them, your SQL will still provide the same data, but will be more executed more efficiently. So this is the same idea, to discover redundant parts, to remove them from a data processing process, data integration process. And then we would like to be able to use some temporary data that could be shared within the same data integration process and to be shared between different data integration processes. So another issue is how to discover these temporary data that could be shared and to provide means for discovering redundant data, redundant subtasks and temporary data. You have to have access, full access to data integration tasks. They must be treated as white boxes, fully open. But the problem is, this is the third problem, that typically data integration processes often use user-defined functions that are treated as black boxes, fully hermetical. You don't know anything about these black boxes. So a cost model is unknown, typically. You have to discover it, learn it. The semantics of a black box is unknown or partially known. You have to discover it. And third, user-defined functions are frequently executed outside of data integration engine. It's just a call to an external program and it returns back some data. So you don't have any control on black boxes. And this is a great challenge in optimizing data integration processes. Okay, what are the approaches to data integration processes optimization? Of course, increasing resources increasing the number of CPUs, memory, the number of nodes for a data integration engine. Then parallelizing ETL or data integration processes, running such processes in a cluster. And such kind of parallelization is supported by every major data integration engine on the market. Listed some of them, the most popular are listed on this slide. Then another approach used in business is moving tasks to decrease data volume as soon as possible. It's again the same concept as applied for SQL optimization. Move the most selective parts of query execution plan to the bottom, to the sources, the tables. So this is the same idea. Executing filtering as soon as possible is a kind of heuristic. Then another approach is moving execution of some task into a data source or into a data warehouse, if we are talking about a data warehouse architecture. And this concept is called the balanced optimization, supported in this software, push-down optimization, supported in this software, and queried and easy data, supported in this software. But these kind of optimization techniques are constrained to tasks expressed by SQL. Okay, research approaches to ETL or to data integration performance optimization, partition and parallelization, and reordering. Two techniques. Partition and parallelization means that a data integration process is partitioned into linear flows, And there are two types of partitions, vertical and horizontal. I'm not going to discuss this in details, but there is the whole data integration process is here, and it's partitioned into linear flows. One linear flow, another linear flow, another linear flow. Okay, and then these linear flows are optimized independently. How? By inside partition parallelization, you execute this flow, this, or some tasks in these flows in parallel. And then the third level of optimization is multi-threading of individual tasks like these boxes. Then reordering based on costs, execution costs of data integration process and execution costs of individual tasks. And the cost includes time and data volume, typically. And the idea of reordering is very simple: to reorder the tasks so that after reordering, the cost of executing the whole workflow is lower than before reordering. Okay, but there is a problem, of course, if this workflow is small, you can test all the possible reorderings that make sense. If such a workflow includes dozens of tasks, testing all possible feasible reorderings is not feasible because it's exponential. The complexity is exponential. So there are some pruning techniques, some heuristics to constrain the search space of all possible reorderings. As an example of a simple reordering, we can consider the two different data integration processes. Both of them do the same. There are two data sources, sales in Polish zloty and sales in euro, so different prices, different date formats in these data sources, and different granularity of data. The blue one stores monthly sales, the green one stores daily sales. And then there is the original workflow. And if you reorder these steps, like as shown here, you can gain some time of course, I'm not going to discuss this in detail because time is running, but this workflow is definitely more efficient than the first one. We eliminated one unnecessary task. We moved the most selective tasks to the beginning of the workflow, and then we apply some reorderings here to reduce the amount of data pushed through this pipeline as soon as possible. So this is the basic idea of reordering. Summary one of this part. The problem of optimizing data integration processes is known for decades, and so far it has only been partially solved. So that shows that this is a really difficult problem. Optimization techniques applied in practice and research, parallelization, yes, commercial approaches and research, balanced push down, yes, commercial and research approaches. Task reordering is a research approach. Task reordering is computationally complex. Parallelization is promising, feasible and promising, but there are some still open problems, determining the optimal number of parallel flows, determining the optimal amount of resources for a given task to be parallelized. One criterion is to reduce the time. The other one is to reduce the monetary cost if you run it in a cloud. And then which parallelization skeleton to apply? There are different parallelization skeletons, which would be the best for a given task or for the whole workflow. And the cost-based optimization is still an open problem. Okay, data integration processes with user-defined functions. Already difficult problem of data integration process optimization, but we add to it yet another dimension of complexity. UDFs are treated as black boxes. How to open a black box? Okay, there are some approaches. Annotating a code of a black box. You provide some hints. I mean, a programmer provides some hints while implementing a UDF. Then Java bytecode analysis, another approach. And then the third one is reverse engineering of UDFs implemented as SQL only SQL. And the next issue is discovering performance characteristics of a UDF to build a performance model that you would be able to, based on this model, you would be able to assess the cost or execution cost of a given UDF. And these are still, even if there are some approaches to solve this problem, this is still unsolved, not fully solved. And what we propose, this is our research work with IBM, opening a black box by means of discovering patterns in resource usage. For example, we can observe here, this is CPU usage. The red one is CPU usage of a UDF computing an average. Very simple UDF, but we just started the project. So this one is for a given data volume, and the right one uses twice as big volume as the first. And the blue one shows memory usage. And certainly we see here, I think everybody sees that there is a certain pattern, there is a certain similarity of resource usage of the same UDF for different data volumes. There is a pattern. So we work on this, how to build a model of UDF based on resource usage, how to discover which resource, pattern, resource usage patterns are similar, how similar they are. This is not a trivial task. Summary 2 of my talk. The support for optimization of data integration processes with UDFs is still open research problem, very difficult. And we think that learning performance models of UDFs can be supported using machine learning. The third challenge is data processing workflows in data science. What's going on in data science is that those data scientists get data in files, typically CSV files. Then they apply different different programs in different languages, typically Python, R, or Scala, to process these original data. They produce another set of files. Okay, then they apply another transformation, because in fact, this is a data integration process, typical data integration process. So they produce this process produces different files, but they are always files. And finally, the output is one big or a set of files that are analyzed by other programs, Python, R, spreadsheets, of course, data analytics platforms or programs like Tableau, Power BI, and others. So that's the typical data processing workflow in data science. Data, once again, data are stored in files. Also, there is a performance problem in processing data in files. No backup and recovery, at least not the advanced one. The only backup and recovery is at the operating system level. No access control. Data and code sharing is difficult. Every data scientist writes her own code, typically. So reusability of code is low, and as a consequence, there is a low programming productivity. Why is that? Because this data processing workflow neglects or misses data engineering solutions. So what we proposed, this is a kind of vision. We propose to build data processing workflows using a three-layered approach. This is not new, because there is a conceptual model. We propose to use a conceptual model of a data integration workflow. Then, based on this conceptual model, you create, or a software creates, its logical model. Logical means, this is abstract. Conceptual is abstract. It does not specify technologies. This is just the logic of your data processing work, of data processing. And then the logical model includes already technologies like relational database management system, PLSQL, SQL, again, RDBMS, Python, for example. So technologies to implement this abstract workflow. And then the third level is the physical model. And this physical model is strongly related to performance. And it specifies resources in terms of hardware, the number of machines, the size of cluster. And then storage of your data inside a database, for example. Row storage, column storage, partitioning, physical data structures, indexes, materialized views, etc. etc. So this is a vision. We would like to have such an approach to designing data processing workflow. But this architecture opens a lot of challenges. For example, cost models for a complex architecture to optimize a data processing workflow at the logical and physical level. Cost model. We need a cost model of individual tasks, and then we have to combine them into the cost model of the whole workflow. And then based on this cost model and based on some characteristics of technologies, some characteristic of physical storage, we have to, while the system, the algorithm, have to provide the most optimal implementation. There are a lot of problems. Self-tuning capabilities. Yes, we would like that the whole staff would be able to self-tune to react to different different data, for example. And to have this architecture working, we need an interoperable metadata model, which is a kind of standard. So these are the three open issues out of many others. And then the last topic is health information systems. As I said, this comes from my recent project for hospital in Poland. The heterogeneity of data in hospitals is enormous, and there are different types of data that we have to deal with. Medical images, there are plethora of medical images formats. Then ultrasound, magnetic resonance, tomography. There are different types of tomography, and in fact, and they produce different types of images of enormous size. These images have enormous size. Then there are different types of time series. Okay, images, time series, patient metadata like name, age, address, etc. Basic data about patients, text data, lab results, again, text data. Then these are rather short data, patient and lab, but then there are physician notes like diagnosis. They are large text data in free text format or some kind of structured, and there are charts. And you have to provide a view, an integrated view on all these data, to provide a holistic view on a patient. You have to integrate these data. Okay, such a heterogeneity is a challenge itself. And then there are some problems like integrated access to multiple data is restricted because data sources, health information systems are closed. You don't have control of them. They are outsourced to multiple companies. In the same hospital, there are multiple different health information systems. Each of them comes from a different vendor, and they are totally closed. So you don't have full access to these systems. Then data quality. Data quality is a real challenge, especially if we're talking about images. They are wrongly annotated images by technicians. Like MRI backbone section L4 may be annotated as an upper body section, which is not true. And such a low quality makes impossible to analyze these data efficiently or provide the meaningful insights. So we plan to apply machine learning for cleaning such wrongly annotated medical images. And analysis in time. I would say this is a standard functionality. To show a trend like LDL cholesterol for a given patient over the last 5 years, these health information systems do not provide such functionality. Nothing. And then this is unbelievable. And then showed a trend of lung X-rays of a given patient over the last 5 years. You would like to see the images one by one, and you would like to have a software, or those physicians would like to have a software that would highlight parts of your lungs that evolved, are muted, for example, in time. So such functionality like analysis in time doesn't exist. As a summary, or summary 4, and the summary of my talk, This is again taken from a DBLP. A keyword was health informatics. Look at as the interest of research community in health informatics grows in time. And this is health informatics is one of the key fields of application. It's even stressed by the European Union that would be the field of research and application. So that concludes my talk. Thank you for your attention. I hope we have some, 30 seconds for questions.
Okay, thank you, Professor Robert, for the interesting talk. The talk discussed new research directions, which is helpful for many of us. Actually, we don't have that much of time for question, if there's any question. I have a question. You mentioned in your talk that you employed reordering to reduce amount of data. Is there any limitation on this process?
Of course, you have, let's assume that there are two tasks, task 1, task 2, and then if you swap them, it may, your workflow may don't work, because you have to consider what is the input and output, what is the interface of these tasks that you are swapping. So the interface, if you move this task here, it must fit the task that is connecting this task, this moved task. So there is, you cannot swap everything with everything. There are some, in 1 or 2 papers, there were proposed some criteria that guide what you can swap with what. But I'm not going to, of course, to explain this in details, I would need some slides, but generally the interface, input and output interface of a task that you move must fit into the output and input interface of other tasks in the place where you move this task. So that's the main constraint.
Okay, thank you. By the way, we have over 90 persons attending this keynote speech virtually, and we have the same number almost here in the hall. Thank you for your interesting talk. It is recorded and it will be posted on the conference website to be watching in the future. I think we will have much more questions. We will contact you about it, but the lack of time is a limitation here. Thank you very much, Professor Robert.
Thank you, my pleasure.
Okay, thank you. And our second keynote speaker today is Professor Monadiab. My colleague here will introduce her to chair the next keynote session. Professor Mona, are you with us?
Yes. Assalamu alaikum.
Bismillah ar-Rahman ar-Rahim. In the name of Allah, most gracious and merciful, ladies and gentlemen, I would like to introduce to you Prof. Monadiab, full professor of Computer Science Department at George Washington University. Prof. Mona's general research is at natural language processing and applied machine learning. Furthermore, her research interests span several areas in computational linguistics and natural language processing. Please welcome today Prof. Mona which will present to you a talk entitled Faithfulness in Natural Language Generation in an Era of Heightened Ethical Artificial Intelligence Awareness. Thank you.
Assalamu alaikum, and thanks a lot for your invitation. It's an honor and privilege to be here. Thank you so much for inviting me, and I hope, can everybody hear me? I'm not sure.
Yes, it's okay.
Perfect, excellent. Hopefully this will be clear. So I'm going to talk about faithfulness, faithful natural generation, era of ethical awareness. And specifically, I'm going to focus on opportunities for machine translation as a natural language generation problem. My affiliation, I'm actually a research scientist with Facebook AI, as well as a professor of computer science at George Washington University. And I work in natural language processing and machine learning. So let's begin. As a disclaimer, all the source examples are reflective of true use cases, but with alteration for privacy and anonymity purposes. All machine translation output is authentic from various industrial machine translation systems. And there will be some profanities and racist language on some of the slides, but they're only used to illustrate real phenomena encountered in social media. So what is machine translation's mission? Machine translation is to transcend language barriers to facilitate communication and empower people to have unimpeded knowledge and information access. Machine translation is a utility. It serves peoples in their daily lives, and it plays a pivotal role in people's lives, especially in an era of heightened ethical awareness. So what is our overarching proposal? The overarching proposal is to adopt faithfulness as an objective for machine translation, a la other natural language generation technologies such as summarization. So what does this entail? It entails creating evaluation metrics that optimize for faithfulness, which also entails building faithfulness-aware models and data sets. So what is faithfulness in MT? At a high level, that means generating translations that are exactly equivalent to the source. Other natural language generation technologies, such as faithful abstractive summarization evaluation, the task, oh, you can't see my screen? Can you see my screen?
Yeah. Yes.
Oh, okay. Sorry, I thought I got a message saying you can't see my screen.
No.
Yeah, okay. So faithful abstractive summarization evaluation. So the task in the case of summaries is to produce summaries based on a single or multiple documents in a collection of documents. And faithful summaries are expected to be reflective of the source and only the source with no hallucination. So, and they're typically in a single language. But mind you, it doesn't say much about coverage of all the information in the source as long as it doesn't insert unwarranted information. So that's different from machine translation. And then I want to define what does it mean to live in an era of ethical awareness. Currently, we talk a lot about equality, and this is a definition inspired by responsible artificial intelligence within Facebook, where we cater to all groups and all languages, including dialects and vernaculars, with the same level of service, thereby treat people equally and minimize unjustified differences in outcome. Equity. So this definition is also inspired by Facebook AI, specifically responsible AI within Facebook, where we talk about understanding whether there are groups that deserve special consideration and make a deliberate decision to prioritize outcomes for these disenfranchised. We want to avoid harm and minimize bias. We want to minimize misrepresentation going beyond basic equity and equality to address quality. And we want to increase transparency. So basically clearly communicate the quality reflecting our confidence in the generated text. Faithfulness serves ethical considerations better than current common MT mindset optimizing for adequacy and fluency only. So let me start by delving a little bit more technical into this talk. So state of the art in machine translation today. So here we have an Arabic statement. هذا البرنامج في أمريكا يجمع معلمي اللغة الإنجليزية محللين محليين مع معلمين من حول العالم 6 أسابيع لتدريبهم على أحدث طرق تدريس اللغة الإنجليزية. The machine translation for this is the program in America brings together local English language teachers with teachers from around the world for 6 weeks to train them in the latest methods of teaching English. I don't know about you guys, but I think it's an excellent translation. I hope you agree. And if you try to do a back translation, using the machine translation system to go from the English translation back to Arabic, you could actually see the Arabic, in my opinion, it's even better than the original Arabic source. So it says, يجمع هذا البرنامج في أمريكا. Excuse me, I don't know what's going on with my throat. بين معلمي اللغة الإنجليزية المحليين ومعلمين من جميع أنحاء العالم لمدة 6 أسابيع لتدريبهم على أحدث طرق تدريس الإنجليزية. So it's not too bad. So thinking about machine translation, where we are today, or where we were very recently, state-of-the-art commercial machine translations as of 2018, the quality of machine translation systems was evaluated by a company called Intento. And this graph indicates that, comparing different major machine translation providers like DeepL, Google, IBM, Baidu, SDL, and the numbers you see on each of these bars indicates the number of languages. So they evaluated 48 language pairs, which each comprise 900 to 3,000 sentences per pair. And essentially, the data was mostly edited text, including WMT data, collections to date, metric, and the metric that was used was a human, what's called LE-POR, which is a variant of BLEU. Basically, what BLEU does is a metric that measures the word overlap between the resulting translation and a reference translation. So the machine translation quality was not too bad. Like you get for 15 language on average for DeepL was somewhere around 70%. The average for Google was around 68 to 70% also. Other machine translation systems all the way down. So it wasn't too bad, but then this is edited text. If we take a deeper look at this same set of commercial systems, we see that in general, the machine translation for going from a foreign language or like from an XX language to English achieved higher performance than English going into XX, except for Japanese and Turkish. English to XX much lower for low resource languages, where you don't have enough resources, say like Czech, Turkish, Finnish, Korean, and Arabic. Non-English directions, 16 out of the 18 show much poorer performance. And out of the 12 machine translation systems considered, only a max of 6 systems were considered competitive. And so it tells you that there is still a long way to go. So let's take a look back at my example here. So the example that I showed you came from Modern Standard Arabic, from Fusha, which is well-formed, well-edited text. What is the state of the art for social media? And this is the crux of where we have problems. So let's take a look here at some examples. So from Arabic to English, it says, the example here says, قدموا هون من خلال الرابط. And the machine translation the best machine translation system that's out there for Arabic says something like, they provided here through the link, as opposed to apply here through the link. Several examples from English to French, don't forget to hit me up, was translated to, if you think about the back translation, it was translated to don't hesitate to hit me, as opposed to hit me up. From Arabic to English, this is Tunisian, so Gardit al-Fishi was just literally transliterated, wasn't even translated. Vote him out became Sawat li-Salihi, as opposed, which means vote for him, which means is the opposite of the meaning in English, which means kharagu bil-intikhabat. And the last example here shows you how some derogatory words and profanities are introduced by Fiat, even though it says walked my dog in the street. So we did a little evaluation on even within English. So this is not even looking at too far out from vernaculars, and specifically for African American English, we note that if you train the system on standard American English and test the system on African American English, we notice that there is a drop in performance across different machine translation systems that are commercially available, and they're considered state-of-the-art from French to English, which is supposedly, one of the very easy language directions. So why should we care? The number of users who get their news from social media platforms in the United States went up from 28% to 34% in 2018. But globally, we know that around 77% of internet users rely on social media for their news. And if we think about the level of penetration of social media in the world, we're looking at around 3.96 billion people use the internet and they're actually that number are actively using social media. We at Facebook actually generate literally 20 billion translations per day across our family of apps. So this is something that's extremely, relevant to our business as well as to the world at large. The current mindset in machine translation is basically optimizing for fluency and adequacy. And essentially, what does that mean? We're trying to get the most fluent output, so things that make sense when you read through them. And they also have enough semantic meaning carried over from the source to the target, where the source is one language and the target is another language. So when you think about it, the current mindset has a source that looks like this. It goes through some kind of a black box, and you end up getting a translation that looks like that. Note here the empty extra bar here. So there's information loss that happens when you go through this process. So this current mindset renders that. People say, in 2020, there was a big article that indicated that fluency and adequacy are possibly sufficient, especially for Newswire. So there is a Cubbett paper that shows that MT performance passes the human Turing test from English to Czech Newswire. And it says actually even the adequacy is higher than fluency, which means that people care a lot about that the systems are doing really well with adequacy. But again, this is edited text. So what is our desiderata here? We would like to ideally shoot for a North Star, where we have a source that's completely transformed over to the target without any loss in information. And at the same time, we have understanding of what's happening in the middle here. I'm not going to talk about this middle part today, but I'm trying to motivate you to think about how can we preserve the signal better. So what is faithful MT? It's not about prayers or supplications. It's about producing machine translation that is faithful to the source, reflecting the exact meaning of the source with no additions, aka no hallucinations, deletions, or egregious substitutions. So going beyond translation ease. But what it is not, it's not a judgment on the veridicality, the truthfulness of the content, and it's not a judgment on the provenance of the source. So you don't need to know where it came from. In a nutshell, faithful translation is about achieving meaning, expression, and usage equivalence with the source while maintaining minimal distance. So what is the proposal? It's a mindset shift, moving beyond the MVP, the minimum viable product mindset, to adopting a faithfulness mindset. Go beyond adequate meaning and fluency to include usage considerations, for meaning specifically pragmatics. So what do we mean by that? Emotional intensity, reflecting trends as they have downstream implications. Level of formality, coherence in a post as part of the message. Use of idiomatic expressions, conveying cultural nuance. Hedging in a message has implications, for example, deception detection. Sarcasm, irony, for example, humor versus hate speech detection. Especially, it's increasingly important in social media and opinion data, subjective data. So for social computing purposes. So what are the potential implications of shifting our mindset? If we adopt faithfulness mindset, it allows for us to think of other approaches to evaluation, task-based evaluation frameworks, and it serves as a forcing function towards building more interpretable models. So here is kind of like the Venn diagram that I like to show, where faithfulness really encompasses fluency and adequacy, but it also encompasses plausibility. So what is plausibility? Let me show you what I mean by that. Just to give you an example, plausibility refers to how likely is translation to appear in a target language. So you have this expression, you made my day, and it gets translated verbatim into Intasarat Yaomi. But we know that this is not something that somebody says in Arabic. So verbatim, it means you built, manufactured my day. It's fluent Arabic, but quite implausible. The correct faithful translation would be something like Farrahtini, Egyptian Arabic. So faithfulness beyond fluency. Typically, we aim for fluency as the most in the target, almost ignoring source fluency. However, in social media, speech effects play a pragmatic role. For example, بحب الكورة قوي could be fluently translated to I love football very much, or a faithful translation would be I love football very much. And this expression is important to relay because it shows the emphasis of how much they love football. Faithfulness beyond adequacy. So in the source, the adequate translation would be something like, the dress is nice, it will eat a piece from you. But we know it's weird. But in English, we say something like, the dress is stunning, it really fits you nicely. Again, the president is close to his people. Rais قريب من شعبه would be an adequate translation. A faithful translation would be something like, Rais محبوب من شعبه. President is admired by his people. What throws users off? Typically, catastrophic translations. So when people mistranslate named entities such as Simsim, become Sesame, wrong pronouns, it, he, instead of a she, deleting critical information, false profanities, such as dog translating to the derogatory word, implausible translations, made my day, God Naomi, introduction of violent terms, oppose them, becomes attack them, reverse polarity, vote him out, votez pour lui, vote for him, and hallucinating unwarranted target text. I would surmise that the first three are an adequacy problem, and the last set, the last five or so, are faithfulness problems. So back to our picture of, that I had around social media and the performance there. In fact, several of these would be, adequacy problems, but a couple of them are still faithfulness problems that cannot just be addressed by adequacy and fluency alone. So if our MVP is not there for social media, so the minimum viable product is not there for social media, why even think of faithfulness? Shouldn't we just aim for MVP, fluency, adequacy, and then think of faithfulness? Isn't faithfulness a luxury, a nice to have? My argument is not, especially in subjective data, social media and opinion data, where pragmatics are crucial. For example, super relate, silent treatment to the max. The MT, super is calling. And then MT, my bitch walked down the street versus walked my dog in the street. So these things make a big difference in meaning. So what's the challenge of pragmatic phenomena? Many of these pragmatic phenomena are high type, low token frequency, expressed with very high variability. So like named entities, proper names, idiomatic expressions, neologisms, hashtags. Social media seems to expedite new expressions also being coined in the language. So it's very dynamic. Tapping into the generation's used creativity. And the problem is really exacerbated for low resource languages such as dialectal variants. So think about the different Arabics that we speak in the Arab world, like Jordanian Arabic, Egyptian Arabic, Tunisian Arabic. Computational linguistic technology challenges. So negation detection is still an unsolved problem. Sarcasm detection, humor detection and translation, quantifier scope, to name a few. So what would it take to get there? Addressing style correspondence. So hey you all, what's up? The faithful translation would be something like Salam ya jama'a akhbarkum eh, versus adequate translation, As-salam ya rifaq ma akhbarakum. It's okay, but it sounds like a cartoon. It's not really the way we speak. Addressing emotional intensity. ساعات بحب أكل sushi في العشاء. A faithful translation would be, sometimes I like to eat sushi for dinner. Adequate translation would be, I love to eat sushi for dinner for hours. It's a weird translation. It's adequate, but it doesn't portray the same meaning and emotional intensity that's in the faithful translation. Addressing modality and specifically belief modality. GM may lay off workers. Faithful translation would be GM قد تسرح العمال versus adequate translation GM ستسرح العمال. GM will lay off workers, and that makes a huge difference. The fact that it might is not transferred over in the adequate translation, and I bet you none of our machine translation evaluation frameworks is able to pick this up. Addressing hallucinations, especially around profanities. So for example, the poor are demanding their rights in America. The adequate translation would be the deplorable people are demanding their right to life in America. Addressing idiomatic expressions. So these are sort of like multi-word expressions. شفتوا يا ناس فلوس العرب بتروح فين في الهواء الطلق. The faithful translation would be, people, did you see where the Arab wealth is going? into thin air. Adequate translation, did you see where Arab money goes? Outdoors. So outdoors versus into thin air makes a big difference in expression. Addressing sarcasm. Faithful translation would be, wow, what audacity, dude, versus, oh, peace be on your daring attitude, bro, which is like, what? It's a weird expression in English. Addressing code switching. So, قدموا هون من خلال الرابط. It's really applied through this link, and the adequate translation that arrived here through the link, which is a bad translation. And French and MSA, so gardite malaf, save the file, I save the file. So what would it take to get there? Addressing other phenomena like shorthand, LOL, talk to you later, neologisms, frenemy, noob, hashtags, humor and irony, negation, quantifier scoping, etc. So there are modeling considerations that we should take into account. Is there a light at the end of the tunnel? Yes, there is. So there is work that is relatively recent addressing pragmatics and machine translation. Data augmentation for a specific phenomenon. So there is work by Zinaniello and Birch in 2020 where multi-word expressions aware machine translation was used. And they did this for English to Italian. And they looked at ways of augmenting training data with multi-word expression parallel dictionary lists. They also looked at leveraging MWE detection tools for source language, and they applied factored neural machine translation. I'm not going to go into any of these in detail, but there are technologies that work. But basically, the back translation yielded the highest results with a 1.3% increase in what's called the BLEU score, which I mentioned earlier on. And for the specific test set that had multi-word expressions, like all these idiomatic expressions, it went up by 5 points, which is really, really significant. There's also style transfer in NMT called controlled formality generation. And this is work by Neo et al. And essentially the idea there was that they did multitask learning, performing both bidirectional English formality transfer and translated the XX into English with desired formality. And the results they received, they showed they yielded comparable results to state-of-the-art supervised side constraints. Hallucination detection in neural sequence generation. And this is work that we just got accepted to actually ACL. And the idea here was that we were able to detect hallucination in both machine translation and sarcasm, and summaries and summarization. And then there are several enabling technologies for pragmatics, like style transfer using supervised and unsupervised and semi-supervised methods, emotion intensity classification, sarcasm detection, level of committed belief, and similarly for negation detection, multi-word expression classification, interest-intentional code switching, and using various integration modeling techniques like side constraints, projections through parallel corpora, leveraging cross-language embeddings for comparable and related corpora, and also leveraging multitask learning and pre-trained language models. So the caveat here, though, is that the majority of these systems exist for English or at best for high resource languages. So, and MT already is a problem that is really English-centric, since most translation directions lack direct L1 into L2 parallel data, so machine translation systems pivot through English. So what happens is that L1 gets translated into English and English back to L2. So you can imagine this is a problem, right? So think you're trying to translate from English to, from Arabic to Russian, where both languages have, they're explicitly morphologically rich. They have gender, they have a number explicitly marked on their verbs and nouns. And then once you go through English, that gets dropped because, English is blind to these phenomena. So when you're transferring from Russian, say, to Arabic, you could lose the feminine pronoun or the feminine, suffix and so on and so forth. So what's the way to mitigate this, mitigating the English-centric bias? A possible solution is to increase the pool of pivot languages with various language family representations. So there are 13 to 14 language families. We look at varying typologies and look for a representative that's high resource enough as much as possible. And we have previous work on exploiting language relatedness in more creative ways, especially for machine translation, natural language generation from 2015. There is also evaluation considerations in this setting. So one of the shortcomings of the current state of the art, or not state of the art, but actually the common practice of metrics is for bleu. So if you have an example like I did not go to the office, a machine translation that renders I have not been to the office, even though it's the correct translation, is considered much worse than I did go to the office, which is exactly the polar opposite of the statement in the source language. So what are the desiderata? We want to create targeted data sets that reflect relevant faithfulness phenomena, develop metrics that focus on equivalence, optimizing for faithfulness rather than translation ease. So things like semantic textual similarity, minimizing reliance on references, grounding evaluation user studies on a continuous basis, and invest in automated relevant enabling technologies, so hallucination detection, and adopt task-based evaluation paradigms such as question answering to address critical errors. Another thing that people have done in terms of data sets, we've seen gender balanced generation. So there's work by Habash et al. In 2019 around automatic gender identification and reinflection in Arabic. And basically the approach there was to do a joint neural model for gender identification and gender reinflection to create balanced empty output in Arabic. And it achieves an 8-point relative blue improvement in the results on gender detection. But again, all these solutions and considerations are for higher resource languages, where are ethical considerations of equity and equality. So at Facebook, we have developed a data set called Flores, which focuses on extremely low resource languages like Nepalese, Sinhala, and so on. And this data set is publicly available for people to evaluate and use. Another effort that has been going on from people in my group was around doing multilingual training. And we show that with multilingual training, we can boost performance significantly. So the numbers go up, even though you have very low resources, say from 4K to 10K, it goes up from 11.6 to 18.9 for these languages. And on average, you see an improvement if you do multilingual training from compared to bilingual training across the board. And we see diminishing results as we go further in terms of resources. So the resources here are the lowest to the highest going up. But we see significant improvements across the board. So what are the open challenges and opportunities to the community? What does it mean to really model fluency? What does it really mean to model humor that doesn't transfer over? How do we deal with neologisms, smooth, selfie frenemy, typos in the source, shorthand, talk to you later, LOL, etc., and hashtags? How do we handle code switching on the input? How do we generate code switching where appropriate? How do we handle source incoherence? What are reference translations that are complicated to generate, especially for low resource scenarios, languages and dialects, resulting in evaluation implications? So what is the take-home message? I'd like us to rise above the inherent mediocrity of an MVP. There are a lot more questions than answers, but I think shifting our mindset to consider faithfulness as necessary, not optional, keeping our eye open on ethical dimensions of our solutions, and potentially a mindset shift from only optimizing for fluency and adequacy and optimizing for faithfulness will result in hybridization of minimal feature engineering and representation, lending a hand to interpretability. We need to be creative about our evaluation and grounded in user experience. And I feel like this is a concerted community effort that's needed to get there. Thank you very much for listening, and let the conversation begin. And I'm ready to take your questions.
Okay. Thank you, Prof. Muna, for your inspiring presentation. By the way, we have around 100 persons participants attending the keynote online, and around the same in the hall. Please, anyone wants to ask any question? Okay, thank you, Prof. Muna, again, and for your presentation. Now, the following sessions will be held in the IT faculty according to the conference program. Thank you very much.
Thank you.